So, what is this hypothesis? This little diagram, or cartoon if you like, is taken from one of Dr. Besant's papers. I've squashed it a little to get it on the page, but that's his diagram, not mine. And although the wording here is my own, it is based very closely on his article. So the hypothesis I'm going to explain here applies to him and also to NIST, although there are a few minor disagreements. So there are 5 stages to this collapse. Number 1, which is represented on the far left in the diagram, the plane hits and causes damage. And we could get into that in detail. The NIST report studies that in great detail. How many columns were severed, how many were damaged, what did the fire do, blah, blah, blah. But it doesn't matter to us right now. Number 2, the columns, steel columns holding up the building in the damaged area, that means where the plane hit, start to buckle. 3, the upper rigid block, and that means the part of the building above the damaged area, above where the plane went in, and that upper rigid block is described by NIST as intact, largely uninjured. It's true that it was a deadly place for human beings, but the building itself was intact, strong, and rigid. It's referred to often as the upper rigid block. Well, as the columns lose their structural strength through buckling, the upper rigid block goes into free fall, and then we have stage 4, which I've called wham, sudden impact. Now, wham is really important here, and I'm going to be coming back to it and paying quite a bit of attention to it, because wham is why we call it the sledgehammer hypothesis. It means that the top part of the building fell on the lower part of the building and smashed it to bits in the way that you saw a few moments ago, turning it into fine powder and gravel and all the rest of it, smashing it. Well, that's quite the sledgehammer. And of course, stage 5 is the progressive collapse of the entire building, and you can see that Dr. Besant has shown his sledgehammer looking very healthy indeed. It hasn't apparently lost any rigidity, any mass. It's just as big as it was before, but somehow the building below it is being squashed and smashed. If any of you have studied physics, you'll know that Newton's third law of motion is being seriously played around with here, according to which the force with which the top part hits the bottom is the same force with which the bottom part will hit the top. How can the top part be uninjured? You know those Hollywood movies where the guy starts beating people up in the bar and he's just laying them out by the dozen? It means he's got an iron fist and all his opponents have a glass jaw. We accept that as a Hollywood convention. But we know that reality is not like that. We know that the force with which the guy hits somebody's jaw is the same as the force with which the jaw hits his fist. And that's why in reality you get a lot of broken fists. Now, I'm saying that even just looking at this diagram, I'm starting to have serious problems. However, I'm going to let that go for now. I'm going to turn, however, from this little diagram to reality. What this hypothesis actually says is that the top 12 stories, we're looking at the North Tower here, fell on the bottom 98 stories and crushed them. Thank you. It's a healthy reaction. Remember, they're made of the same stuff. Remember, in fact, that the columns in this tower taper as they go up. So the top 12 stories are actually lighter and weaker than corresponding segments of 12 stories would be further down in the building. Now, it's true that of these 98 stories, sorry, what happened here? It's true that of the 98 stories, the top 6 of them are damaged by the plane, but the 91 stories below that, says NIST, are in perfectly fine shape, neither damaged by the planes nor by fire. And we'll be seeing later that that was a pretty darn strong 91 stories. Tony especially will explain that to you. But never mind. This is what happened. And this is what it looked like in practice. This is real time. Quarter of a mile high building. The first cloud of debris hits in 10 seconds. The building then flows down to the ground over the next 9 seconds. All that is left are a few core columns of the building. We sometimes refer to this as the spire. And they fall a few seconds after this video clip ends. And the building is now starting to flow in all directions. Wow, what a sledgehammer that was. There are many things that intrigue me about this, but one of them is the symmetry. Just watch it. Just look at it. Symmetrical, enormously forceful, throwing matter out great distances, much wider than the building itself. The distinct plumes, again. The transformation of state that the building goes through as it comes down. And I've said often that I could probably buy this hypothesis if this upper rigid block were made of an entirely different substance from the rest of the tower. If the top 12 stories were made of steel, and the rest of the building was stacked wine glasses, for example, then I could buy this. But of course, it was not stacked wine glasses. This was a very strong building with very strong columns, which you see here as the building is being constructed. There were two main kinds of columns. On the left, you'll see the columns in the core of the building. And don't be confused when people refer to it as a hollow tube and so on. The inside of the building, the core of the building, had these enormous columns, which were also bound to each other horizontally through very strong beams, as you can see. It also had perimeter columns, which you see in the middle of this picture and distant from you. 236 of these, 47 core, 236 perimeter columns. The perimeter columns went all around the building and were bound to each other vertically and horizontally in a very solid way. Although they were smaller, they were made of even higher strength steel than the core columns. Together, these made for a very strong tower, and therefore, remember that when we see this, we have to ask ourselves, how on earth did that upper rigid block, which was compared to the rest of the building quite light, how on earth did it manage not only to initiate collapse, but to keep smashing it all the way to the ground, including those massive columns? So at this point, my friends, we're starting to have some questions, I hope, about this $20 million study by scientists. You see, it's supposed to intimidate us. We're just folks. We're supposed to buy this. Well, I don't buy it, and I hope you don't either. But so far, I've been talking in a kind of casual, informal, yeah, you're right, it keeps getting loose. I've been talking, thank you, in an informal way, just getting you to look carefully, more carefully than we normally do, to have patience, to ask questions. And now I want to go a little extra step further. I want to take one particular part of this hypothesis, and I could have taken different parts, but I want to take this because this is something I did do some research on myself and subject it to a simple observational test. So I'm interested in stage 4, which I put in red, wham, sudden impact. Let's think about that for a minute. Now, if you were trying to hammer a wooden stake into the ground with a sledgehammer, I'm sure that many of you have had to do this at some point in your life, you know that you feel that impact, you feel that jolt.